10 myths about distributed systems that trick cloud professionals. Like this video, subscribe to the channel, follow the playlist, and visit systemsarchitect.io.
Retries make a system more reliable. If a call fails, automate retries and you make the system more reliable.
Not true, though it holds in one narrow case. Retries do fix a one-off blip, which is why most SDKs enable them. They're useless once the service itself is already failing. Why do retries make it worse? A service that's already struggling gets triple the traffic from retries alone, which can make it worse. That arrives exactly when it has the least capacity to handle it. Wait longer between attempts. Add randomness so clients don't retry together. Cap retries as a share of normal traffic. Send notifications of excessive retries.
Health checks catch failing instances for you. Anything unhealthy gets pulled out of rotation before a user notices.
That one is backwards in a way that bites twice. A simple check does catch a crashed process, which is the obvious failure. It stays blind to the database dying behind it. Making the check deeper creates the opposite problem. If it tests a shared database, every instance fails at once when that database slows. The load balancer then drains your whole fleet. Have each instance report only on its own health. Alert on shared dependencies separately.
Autoscaling handles any spike for you. Traffic climbs, new instances appear, and capacity follows and syncs with demand.
Nope, and the gap is measured in minutes. Autoscaling does keep up with an ordinary ramp, which is what you always see. A real spike is over before the new capacity lands. A real sharp spike arrives in seconds, while new instances take minutes to boot and pass health checks. It's often over before the capacity lands. The instances that do arrive each open their own database connections. Keep warm capacity for known peaks, and shed load while you wait.
Put a queue in front of it and the traffic spike gets absorbed. The queue smooths everything out.
Only half true, and the missing half is time. A queue does absorb a short burst, which is why it feels automatic. It only adds delay once the backlog outgrows your consumers. So what does a queue actually change? A queue turns a capacity problem into a waiting problem. Arrive faster than you drain, and the backlog grows without limit. Consumers then work on requests whose caller gave up minutes ago. Cap the queue, turn arrivals away when it's full. Drop messages past their deadline.
The cache is an optimization, so losing it only makes things slower. Everything still works, just less quickly.
Wrong! And the number nobody rechecks is the reason. A cache miss is harmless while the cache is warm and the database is idle. A cold cache buries that database in seconds. How much load does an empty cache actually send? If your cache answers 95% of reads, emptying it sends your database 20 times its normal traffic. A deploy, a restart, or a batch of keys expiring together all do exactly that. Keep serving old values when a refresh fails. Stagger your expiry times.
The database fails over automatically, so failover is handled. A replica gets promoted and the application carries on.
Not so, and the database is the fast part of this. A managed service does promote a replica in seconds, as the console shows. Your clients keep holding the old address for minutes afterwards. Your application takes far longer to notice than the database takes to switch. Connection pools keep sockets open to the old server. Clients cache the DNS name well past its expiry. Shorten connection lifetimes. Set aggressive timeouts. Use the driver's failover-aware endpoint, and then actually test it. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist.
Replication lag runs in milliseconds, so eventual consistency is fine here. Nobody will ever read a stale value.
Not quite, and your dashboard is why it looks settled. Lag really does stay under a second while the network behaves. It stretches to minutes during a failover, which is exactly when it matters. Lag stretches to minutes during a failover or when one partition runs hot. What does a user do at exactly that moment? That's exactly when a user saves something and reloads to check it. Read from the primary copy right after a write. AWS DynamoDB and Azure Cosmos DB Both offer a fresh read per request.
3 availability zones means the region can't take you down. The workload survives anything short of a meteor.
That's a myth, and it hides where the real limit sits. 3 zones do save you when one data center loses power. They share a regional control plane, and that fails as a unit. Zones protect you from broken hardware, not from the region's own control system. That's the service that starts your instances. When it's down, no zone can give you replacements. Surviving a whole region takes a second region and a failover you've actually tested.
Breaking the monolith into services decouples the teams and the failures. Each service can now fail on its own.
False! At least for the failures, however clean the boxes look. Splitting services does decouple your deploys, and teams ship on their own schedule. The chain of calls between them still fails together. If a request crosses 10 services, each up 99.9% of the time, it succeeds only 99% of the time. That's 7 hours of failures a month instead of 45 minutes. Shorten the chain or break it with a queue or a cached fallback.
Cap says you pick 2 of the 3. We chose availability and partition tolerance, so we traded consistency away.
Not how it works, and the diagram is what keeps it alive. The triangle does describe a real limit during a network partition. Partitions are not something you get to choose. Partition tolerance isn't optional because networks break whether you plan for it or not. The real choice appears only during a break. Refuse the request or answer with stale data. The rest of the time, you're trading speed against freshness. Google Cloud Spanner pays for consistency with slower writes. Every one of these holds right up until the system is under stress, which is the only moment that counts. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist.